A harder one, and very entertaining, was what keeps a train on the track? And of course the answer is, as everyone thinks, the flanges on the wheels. You know, the wheels have some kind of flange on them. But that's not the answer. Those flanges are just safety devices. If the flanges rub against the tracks, you hear a terrible squealing. They're just in case the real mechanism doesn't work. There's another problem with trains that's connected to it. That people all know this about their automobile, that when you go around a corner, the outside wheels have to go further than the inside wheels. And if the wheels were connected on a solid shaft, you couldn't do that. You can't turn the outside wheels further than the inside wheels. And so the shaft is broken in the middle with a gear system. It's called a differential. Did you ever see the differential on a railroad train? No, you look at those wheels under a freight car, and there are the two wheels, and there's a solid steel rod going from one wheel to the other. There's nothing. One turns the same as the other. So now how does it go around a corner, a curve, when the outside wheel has to go further than the inside wheel? And the answer is that the wheels are flanged like this. I mean, not flanged, they're cones. This way. That is, they're a little fatter, closer to the train, and a little thinner further out. If you look closely, you'll see they got this beveled edge. And it's all very simple. When they go around a curve, they slide out on the track a bit, so that this wheel travels on a fatter part, a bigger diameter, and this on a smaller diameter. So when they both turn one turn, this swings further than the other. And that's what keeps it on the track also the same way. Suppose a train's running along on this thing, on the track, and the track's here and here, and the two wheels are exactly balanced, and it's nice and even. Suppose accidentally it gets a bump or something and slides out this way. Then this wheel is on a bigger circumference than this one, but they're on a solid shaft. So when it turns once around, it carries this wheel forward relative to the other and steers the train back on the track. Of course, if it gets too far off on the other side, it goes back and forth, and it stays on the track because the wheels are tapered and the flange is safety. Well, we had a lot of stuff like that we had to learn, you know, to get straightened out before we could become full-fledged members of the fraternity.